Okay, guys, this is Rolando Solis from Advanced Quantitative Reasoning, and we're taking a look at a couple of things for linear regressions. You know what? This is regressing the data. We're going to be taking a look at it, seeing how well it fits a linear model, and all that good fun stuff. So let's go ahead and take a look at this. So first off, we have our data, and this is swimming people. You know, basically, if you ever take a look at Olympic swimmers. Basically you can go ahead and take a look at how their arm span compares to their body height. So we're going to go ahead and take a look at that. So here's height and arm span. And we're going to put that data into a spreadsheet. So of course we're going to come right here, the little green button with the spreadsheet icon. And so first off, we're going to go ahead and name this. So we can name this height. Just like that, and then this right here, arm span, just right here. But you know what? Just to let you know, it's not, the calculator will not allow two words to go ahead and represent a column. So these are the columns. So we just start typing in our information, 172 right there, and then of course you can go 173, and you can go ahead and just put all your information in these two columns, 173. No, it's 17, 173. Whoa, what happened here? I know what happened. It's the little button right here, 173. And you can just put all this information right here, which I've already done on another sheet, so we have all of our information already right here that we have. Okay, so that's everything. So after that, we're going to graph this information. So we're going to go ahead and go over here to this button. It's called the Data and Statistics button. So we're going to create a new document, and you can see some dots. This is where our data is. We're going to click right here, so you can use the pad right here to go ahead and control that. And just click right here. We're going to put height, which is our X, and then Y is going to be our arm span. And so just looking at the data, just right now, just looking at it, we have a positive trend in our data. Also, it's linear in nature, so this is also very strong data because the data is well grouped together. So we're going to go ahead and do a linear regression on this sheet, and then we're going to go ahead and take a really quick look at the residuals. So for the predicted model. So right here, we're going to go ahead and do, let's see, plot. We're going to analyze this. We're going to do a regression, and we want to do a linear regression. So that's our predicted line. So say for instance, if someone was 174 centimeters tall, then we predict that that person would be approximately 176 centimeters tall. So they're basically a square. Basically, that's what we have right here. So if you look at the predicted data, like this point right here, compared to like this data, which is observed data, which is data straight out of the chart, or we want to call that a table. This data, which is our predicted data, is a little bit off of what we predicted, observed. So we're going to get something called residuals. We're going to see how off these data points are from our predicted data. So we're going to go ahead and take a look at this menu. We're going to analyze, and we want the residual plot, not the residual squares, the residual plot. So there's our residual plot. Now this will tell us if the data is appropriate for the model. So one of two things will happen. If it's dead on, all these little points would be appearing right here on this line. So basically it takes the difference in Y. So right here we take the predicted data, and then we take our data right here. So we took the observed data and subtract our predicted data. And so that gives us this amount right here, difference. So we can see that the difference right here, if I go ahead and hover it, it says 173.000, comma, negative 0.37. So this means that since we have this point right here, it's a little bit different. It's negative number. That's the difference between the two. So this is a overestimation. We estimated too much according to the model. Well, right here, if we have this point, we have a positive 2.47. So that means that we have an underestimation. We estimated too much. or not. We estimated not enough. So these are residuals. Now, according to this, the residual has no pattern, so our model is appropriate for our data. So we have that there. So there's another way we can do a regression. We're going to go ahead and click right here. If we do menu, option 6, 1, 3, which is linear regressions, we can do that. We can tell it that the X data is going to be our height and our Y data is going to be the arm span. Just say OK. That gives us our model. So this means that our predicted model has Y equal to 1.02x minus 1.428. So that's what we would use as our model. And that's about it. And that's how you get your model. And just remember, that's Y equal to, and I'm just writing it here just so you can see it, 1.02198 x minus 1.42857. And so that's your function, or your predicted linear model. Thank you very much. See you guys.